Not a happy guy right now, boy. I got cranking on a video, and then the data was full. The camera never told me, so I went to check it. And now I got to go back and do it over again. Maybe I'll do a better job this time. All right. So, on the video, you'll see this is where we left off. 4 minutes in, I did a half hour. So I missed 26 minutes. If I film it again, that's okay. I love doing this. I live for it, right? So, check the conditions. We'll do this quick now. Random, it states, okay? Not gonna write it down, it states it. Normal. Don't know if the last video showed it, okay? You've got to type in your information and do a graph. See if I can remember see if I can, you should type that in now and do it, okay? See how close I come to what I have here. I want to say that the bottom value was 44, and the next one was 45.5, and the last one was, I can't write that there. Out of sorts now, man, out of sorts. Nothing worse than wasting time. So this was 45.5, that was 53. I don't know what the other ones were. I'll see if I still have my calculator. You guys see me have a meltdown on camera, that'd be good. You guys would enjoy it. You would. Where's my calculator? I don't know if that graph is in or if I already had graph the next one. Nope, I still have it. 53, yep. 49.5. So that was 53. 49.5. Now, granted, to do this the right way, let me just do it the right way. I don't like to do things halfway. Okay, so normal. 44, 46, 48, 50, 52, 54. So 44, again, I go in the calculator, I hit trace, okay, I hit trace. 53 was one, 49.5 was another. My median was at 48.5, and then this is 45.5. Okay? And so then what we should do this correctly is we should put a sentence with this. Okay? Since the box plot does not show severe skewness or outliers, we can use the normal approximation. Okay, you should have a sentence. I-12 is less than or equal to 10% of the hours of music played at the station. Okay? There it is, your three conditions. Okay, your three conditions, a big part of your plan. Another big part of your plan is naming the test. It didn't ask us to do that. This is going to be a one sample t-test though. All right. So now they want us to do the nuts and bolts of the problem, get the do part going. Get the do part going. So for this one, the null hypothesis, okay, the null hypothesis was the mean equals 50, which is, the mean is the number of minutes per hour of music. I'm trying to say they don't have a lot of commercials. The alternate, they think it's less than that. U is less than 50. So my formula for a t-score is I use my x bar minus the mean, which they give me, divided by the sample standard deviation divided by the square root of n. Now, they didn't give us this stuff. We have to use the calculator to find it. Okay, we have to use the calculator to find it. So I go to my calculator, and I hit stat, and I go to calc in one variable statistics. My stuff is in L1, and there's my 47.9. So when I go to find my t-score, t equals 47.9 minus the mean, minus 50, divided by the sample standard deviation, 2.81, divided by the square root of n, and n is 12. So when we do that, we should get a t-score of negative 2.59. Their alternate hypothesis says less than 50, so we're going to do TCDF underneath norm CDF, TCDF, negative 999 to negative 2.59, and see what we get for a t-score, or a p-value, I'm sorry, p-value. And that p-value should be, oh, it doesn't tell me, isn't that nice? They use table B. I don't ever use the tables. Use a calculator. It's the best way to do it. Second dister, TCDF, negative 999, 2, negative 2.59. And then my degrees of freedom, I should have it here somewhere, probably comma 11 for my degrees of freedom. Degrees of freedom, T to the left, T to the right, stand up, sit down, fight, 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 and I get something I don't think is right. I don't remember this. 0.0095, 0.0095. I just did this. I don't remember getting that. Let me check. Let me try that again just to make sure. Second dister, TCDF, negative 909. Oh, degrees of freedom, 17. Degrees of freedom is 17. Degrees of freedom is 1 minus this, 11. I don't know why I typed in 17. And I get 0.013. That's what I was looking for. Okay? Off my game now. Off my game. Let me make sure this is still recording. If this isn't recording now, I'm done. D-U-N, done. Oh, hey, look at that. It's recording, 8 minutes in. All right. Next page. So here they want us to find the p-value for a test. Okay, find the p-value using the calculator. We don't use the tables, we use calculators. 21st century here, right? 21st. So here we go. Second district, TCDF. This one's greater than, so we're going to go from 2.33 to 999. Degrees of freedom 74 because the sample size is 75. 0.011. Okay? Try the next one. Try B. See if you get what I get. Second dister, TCDF. It's negative, so I'm going to go negative 999 to negative 0.51, degrees of freedom, 9, p-value 0.311, but guess what, guys? Guess what? I got to take that and multiply it times 2, because it's a two-tailed, and I get 0.6223. So, go to the Check Your Understanding on page 570. Okay, do that Check Your Understanding on 570. Pause the video, please. pause the video, please. All right, here's to check your understanding. Let's do this. Get this out of the way. Test statistic. X bar is 17. So t equals 17 minus the mean, which is 0, divided by the sample standard deviation, which is 60, divided by the square root of n, and is 18, the square root of 17. That must have been that 17 I had in my head from the last problem. Okay? So let's do that. Let's do it. Let's do it. So we get 17 divided by, I'm going to put parentheses around 60, divided by the square root of 17. Should 17 minus 0 divided by tells me I got 1.17. Okay, for a test statistic. It's funny, I don't remember that. Oh, I did minus 1 for this. You don't do minus 1. This is supposed to be an 18. It's Friday, and I totally have it. But I want to hammer through this. I knew it was off a little bit, so I just did it. 1.20. Okay, now I want to find a p-value. So I do second dister, TCDF, 1.20, 999, degrees of freedom. There's 18 workers, so there's 17 degrees of freedom. I got 0.123 for a p-value. Guess what? It's two-tailed because it says not equal to. So then I take that p-value and I multiply that times 2 and I get 0.246. Okay? That's that. Now this is where I left off before. Get right back to it. Construction zones. So this is what I want you guys to do. Please pause the video. Pause the video and see what you can do with this. 4-step process. State, plan, do, conclude. Do it. All right, here we go. State. Restate. Can we conclude that the average speed? Can we conclude that the average speed of drivers in the construction zone, of drivers in the construction zone, is greater than the posted is greater than 25 miles per hour. All right? Now, part of your state is your hypothesis. U equals 25 miles per hour. That's always the status quo. That's always no change. okay? Your null hypothesis, where mu equals the speed of, average speed, of cars in a construction zone. So my alternate, they want to know if the speed's greater. So they want to know if the speed is greater than 25. So there is a very good state. Okay, that is a stellar state right there. Okay, we hit everything. We talked about our parameter of interest. We have our hypotheses, and we labeled and defined our hypotheses. So now we do the plan. The first thing in your plan is to name your test. A 1 sample t test for means. A 1 sample t test for means. Random, normal, independent. It states it was a random sample. Normal. I only got 12. How many scores? What do we got? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 things to base it on here. Okay? 10 things to base it on. So guess what? I can't say it's normal. I can't look at this and say, well, it's normal. And don't say n times p. This is not n times p. That's proportionate. These are means. My means are not greater than 30. I have to graph it. Okay? I have to graph it. So I go to my calculator, and I go to my stat, and I go to my edit, and then I go to here, and I clear it out, enter, and I enter these scores in, 27, 33, 32, 21, 30, 30, 29, 25, 27, 34. Guess what? Looks like the speeds are going to be greater than 25. If you asked me to look at that and tell you. Okay, so what do I have to do with that? I have to get a graph. I'm going to go to second step, plot, and then graph it. Okay, and I'm going to fit it. So let's do zoom fit. Zoom 9. Look at that. There's my graph. Okay, so to figure out my graph, I hit trace, and the first one says 21, so I'm going to make my number line. Make my number line at 20. My last one is 34, 20, 22, 24, 26, 28, 30, 32. So again, I think I said 34, 34. The first one's 21, I put a dash. My next one is 27, whoa, way up there. I put a dash. This one here is 29.5. And then this one's 32, and this one's 34. And someone's going to say, well, wait a minute, Mr. O, that looks really skewed to the left. Yeah, but there's no outliers. Let me see what they say about this. Yeah, they say run with it. Okay, so no severe skew or outliers, so we can use the normal approximation. Okay, independent, we're going to say that 10 speeds, is that what it is? 10, 10, yes. The 10 is less than or equal to 10% of all speeds measured in the construction zone. Okay, or speeds in the zone, maybe not measured. All right? Let's go on to the next part. So I got to do my do. I slid that up. I didn't need to slide it up. I'm going to put my do right underneath here. Okay? So let's do our do step. So we got to come up with a score here. Okay? Now I don't have the value says t equals x bar minus the mean divided by the sample standard deviation divided by the square root of n. I don't know what that is. So I go to my calculator. My calculator is going to tell me that. Okay, so my calculator would say stat Cal?